Welcome to the NASA-Boeing CFT status teleconference. Our event will now begin. Today's conference is being recorded. If you have any objections, you may disconnect at this time. If you would like to ask a question during the Q&A portion of the briefing, please press star 1 to be added to the queue. If you would like to withdraw your question, press star 2. Do not use speakerphone when you are asking your question.
Hi, everyone. This is Leah Cheshire of NASA. Thank you for joining us today for an update on NASA's Boeing Crew Flight Test of NASA astronauts Butch Wilmore and Suni Williams aboard the Starliner spacecraft. Starliner launched on June 5th and docked to the International Space Station on June 6th. And to talk about its mission since then, I have with me Steve Stitch, manager of NASA's Commercial Crew Program, Dana Weigel, manager of NASA's International Space Station Program, Mark Nappy, vice president and program manager for the Commercial Crew Program at Boeing, and Mike Lammers, flight director at NASA's Johnson Space Center in Houston. We will open up for question and answers shortly after opening remarks, but for now, I'm going to start by turning it over to Steve Stitch.
Thank you, Leah, and thanks to everybody out there today for joining us and your continued interest in the Commercial Crew Program and our Starliner crewed flight test. I hope everybody had a wonderful Father's Day. We did give our team the weekend off. They have been working long and hard all the way back to before the first attempts back in early May, so we decided to give the team a little bit of a break on the weekend. I'm going to try to give a comprehensive update of what has been transpiring since we last talked on June 6th after docking. The teams have been very busy reviewing the data and executing the on-orbit flight test objectives for the mission. I would say overall Starliner is doing very well on orbit. This is a test flight. We're taking our time to understand the vehicle and also understand the service module. The service module is a component that we don't get back. As you know, after we execute the deorbit burn, it burns up in the atmosphere, and so we're taking our time to understand that service module and the things that we've had happen relative to the helium leaks and also the thruster fail-offs at docking. Safety is in the foremost part of our mind as we approach the problems and look toward the return of Butch and Suni. It's a test flight. Butch and Suni are doing well. Mike Lammers will talk a little bit more about that, but they are anxious to understand every aspect of Starliner that we can, and even as we got out on the weekend, got them in the vehicle to do the docked hot fire test, which I'll talk a little bit more about. They were anxious, excited, and happy to be there. You can tell every time they get in Starliner, they love the vehicle, they love Starliner, and they're so happy to be a part of the mission. I want to take a step back and talk about what we've been doing over the last two and a half weeks, or week and a half, I'm sorry. What we wanted to make sure that we reviewed all the data from the flight, including all the thruster firings from all the way at the very beginning of the flight, even on flight day 1 before the docking when we had the thruster fail-offs, and also do some additional testing and analysis on the ground that we could prepare for the undock, deorbit, and return. So we've been collecting as much data as possible. I'm going to take a little time today to update you on some of the observations we saw in flight, and I'll do that in a very detailed manner. Before we get into that, I would like to talk about the return date. We are now targeting an undock and return no earlier than June 26th. We've moved off of the 22nd. We want to give our teams a little bit more time to look at the data, do some analysis, and make sure we're really ready to come home. For this opportunity, it's a landing at White Sands Space Harbor on Wednesday the 26th at approximately 4:51 a.m. Eastern or 2:51 a.m. Mountain. An undock would be that Tuesday the 25th at about 10:10 Eastern for that landing. So we've moved that and gave them the time. We did that move also to allow our teams to have time over the weekend to take some time off. We felt like the team was working really hard, and it would be good to give our teams a bit of a break. We do have backup opportunities. As you can see, the pattern is about every 4 days we have a prime opportunity. So that prime opportunity on the 26th is to the White Sands, and the next one would be July 2nd, and that prime would be to Wilcox. So about every 4 days we hear that. ISS is happy to have Butch and Suni to be on board the space station. We're putting them to work and getting a lot of good work out of them. They helped us with the docked hot fire testing. I do appreciate the space station program been really good at helping this mission with a docked hot fire test that I'll talk more about on Saturday, and then also some inspection of some of the thrusters that failed off using the robotic system on the space station. So what's really complicated is, we're going through all the data from this flight, but comparing it to OFT2, and also looking forward to the remainder of the flight and running simulations of the number of thruster pulses and the helium requirements for the remainder of the flight. So let's start with the thrusters. Last time that we spoke just after docking, I told you about 5 reaction control system thrusters. These were all aft thrusters that failed during the final phase of the rendezvous after we had done the TPI burn in that final phase where there's a lot of thruster firings. We had 5 thrusters fail. Thruster B1A3, when we looked at that hot fire data, we saw that it had 11% thrust on one of the firings and then 0% on another. These were the 2 firings that we did on the rendezvous day. And so that thruster, we have decided we are not going to hot fire that thruster anymore. We didn't hot fire it on Saturday. We're just going to leave that thruster alone because it shows a very strange signature where we're getting almost no thrust out of that. So we're going to leave that thruster deselected, and we're not going to use it for the remainder of the flight. We went through, during the hot fire, the first thing we did was a really short pulse, like a quarter of a second pulse on all the thrusters. And we hot fired all 7 of the thrusters, not B1A3, but all 7 of the thrusters, including, 3 of the good thrusters that we didn't see any. We saw very nominal behavior on rendezvous day. When we did that, we saw, really good what we call chamber pressure. And so chamber pressure is a way to measure the health of the thruster in terms of telemetry. I think of it as like measuring the health of your tires on your car. You check the pressure on your tires to see if they're healthy. It needs to be in a certain range. And these thrusters, when they fire, they normally have a chamber pressure trace that looks very normal. And so when we hot fired all the thrusters, they were around the 300 PSI, pounds per square inch measurement. Some were a little bit lower than that. It's really hard with the telemetry system. We have to capture what we would call the peak of that thrust because we only have telemetry at 10 samples per second. So on S2A2, we had a good, that was the starboard, one of the starboard thrusters, had good PC. Also S1A1, the top T2A2 and B2A2 all had good chamber pressure. So each of those had a quarter of a second pulse, and we checked the thrust on that. So coming out of that, we feel very confident in the thrusters, and the team is just making sure to go look at the thrusters in detail across the whole flight and compare them to what happened on OFT2. If you remember on OFT2, during the rendezvous sequence, we had 2 thrusters fail. Both those thrusters came back at the end of the flight, and the team's looking at all that data and comparing it to OFT2. We also took advantage, and this is something that really helps us for future flights while we were docked to ISS, of using the ISS guidance navigation control system to look at the thruster firings. And the way we do that is we fire the thrusters each for about 1.2 seconds, and then we look at the response in the ISS flight control system to measure the acceleration from the thruster. And then also we can use it changes the rate on the vehicle a little bit. ISS weighs 1 million pounds, so it's a very big vehicle. But we can actually back out and see how it's trying to move the station by firing this thruster. So we did that for all 7 thrusters, and all those thrusters look like they have good thrust. In other words, that's the force that's coming out of each of those thrusters. So, for example, I just checked before I came over and looked at the plots. S2A2, S1A1, and B2A2 had almost 100% thrust coming out of that thruster, which means it recovered from the rendezvous day. And we have some theories about what's going on inside the thruster, where when the thruster gets very hot, and we had a lot of pulses and demands put on those thrusters during rendezvous, you can actually get not as good a mixing in the chamber. You need the oxidizer and the fuel to spray, almost like a shower head that sprays together the fuel and the oxidizer mix, and that produces thrust. And so in some cases, we think the heating may have caused the propellants to vaporize a little bit, and we didn't get good mixing, and that's why the thrust was a little bit lower. So remember, we don't get the hardware back. That's why we're taking our time to do this hot fire and collect all the data, and also taking our time to go through and review all the thruster firings for the whole flight, and again compare some of that data to OFT2. It does look like when we look at the 2 flights, the rendezvous was a little bit more demanding on the propulsion system. In other words, it fired thrusters a little bit more frequently, and it fired them in a little bit more rapid succession, and that caused a little extra heating. And so we're trying to understand that as well. We're also in the process of running a lot of simulations to look at the remainder of the flight. So we know what happened on rendezvous day with the thrusters failing off, and we're comparing what happened there to the remainder of the flight. And Michael will talk a little bit more about the undock sequence and the SEP sequence. And, you know, we have two big events, the deorbit burn. We want to understand how the thrusters will perform during the deorbit burn, when they are demanded to fire to hold attitude or hold the orientation of the vehicle during the deorbit burn. And then after that, they're really not used for the separation of the crew module and service module at the very end. Those are a different set of thrusters used for those. So the path forward is really over the next week. We really need to be working this week to try to wrap things up by this Saturday, the 22nd. Our teams are going to look through, and I listened to about a 6-hour review yesterday of all the thruster firing data. They're going to look at that thruster firing data again today and compare it to the GNC simulations. So they're spending time doing that over the rest of the week. On Saturday as well, we had an opportunity to look at the helium leaks on the helium manifolds and get another check of those leaks that I told you about in our post-docking press event. We did have one more leak registered that I was not able to tell you about on the 6th. It's a very small leak that we saw after docking. So that's the 5th leak. It's the smallest of all that we've seen, and very similar to what we saw on OFT2. So on the hot fire on Saturday, we isolated the helium manifolds again, and then we looked at those leak rates. And I would say every single manifold that we looked at, after 9 days being docked, we saw the leak rates going down. And we can provide the leak rates to you. For example, the port helium manifold 2, that's the one that we call the P2D2 flange leak. I'm going to use a little different units this time. It was 11.5 standard cubic centimeters per minute. That's standard cubic centimeters per minute after the docking when we closed the ISO valves. And then after the hot fire, it was 5.6, so it kind of had reduced in half again. Every single manifold, the leak rate had gone down. And so in terms of the helium leaks, we think somehow it's related to, although specifically we don't know the exact cause, it seems to be related to the activity of the thrusters. And if you remember, we saw 2 leaks on flight day 1 after we had done 2 OMAC burns, and then we had some crew flying activities that day where they were maneuvering to attitudes. We saw 2 leaks that day in top manifold 1 and port manifold 1, and then we saw 2 leaks after docking where we fired thrusters significantly on docking day. So it seems to be related to dynamic activity, and what we're doing on the helium leaks is now looking at what's left in the remainder of the flight and how many dynamic activities there are. We've looked at the margin for return. You know, I talked about we need about 7 hours of helium, and we have about 70 hours of margin to get to the deorbit burn. We're actually also doing some seal testing on the ground at the Marshall Space Flight Center. We're purposely damaging a seal, cutting the seal, and putting it in a simulated flange and looking at leak rates. We're also able to take that simulated flange, and heat that flange up and look at leak rates for that. And so we're spending some time doing that. So the path going forward is to continue to look at the helium system, continue to try to understand what's happening. Again, look at simulations for the remainder of the flight. What's our demand? What if we wave off? And what does that mean for the system? And then the operational techniques to manage the helium system. Let's see, we had one more item we worked between the docking and the post-docking and now. We had in the service module, this is a valve that actually is used to isolate propellants. So on the port manifold, there was an RCS oxidizer isolation valve. So this is a prop valve on the oxidizer side that was not properly closing. So the valve was moving clearly, but what we saw on the valve was it was not seating clearly. So in other words, we saw the valve move, but then there's a seed that actually needs to form a good seal so we don't see propellant moving after that valve. We used the other valve in that manifold. The A valve was the one that wasn't functioning. The B valve is now working fine. We used that to isolate the manifold as planned, and so we can work around that for the rest of the flight. This was different than what we saw, you may remember, on Service Module 2, on OFT2 in 2021. We had several oxidizer isolation valves that did not function, during the pre-flight checks. This is different than that. We wanted to go ahead and cycle all the valves and make sure we didn't see any of the signatures that were similar to that service module. We know we had a good ground purge of nitrox and air the entire time from the C3PF into the VIF out to the pad. And so we confirmed that all the valves are functioning on the vehicle, and this signature looks a little bit different. So that issue is closed for flight, and we know how to manage it. We're going to talk a little bit more about some of the Mark Nappy will talk a little bit more about what we've been doing while we've been on orbit, some of the power-ups of the vehicle, habitability checks in safe haven. Meanwhile, we're getting ready for return in parallel to doing all the work on the service module that we need to do to convince ourselves that we have a safe vehicle for return. We want to also understand what this means for the long term. Can we get some data while we're docked that helps us with post-flight troubleshooting? Because sometimes what's interesting about the service module is the best place to do some of this testing is actually on orbit, where we can replicate the thermal exactly in the vehicle and have the entire dock houses connected to the rest of the service module. So the best place for the testing is on orbit. On the ground this weekend, and Mike will talk more about this, we did have a mission dress rehearsal. We had all the recovery teams in place at the White Sands Space Harbor. They went out and simulated a landing. They had the helos present, all the aspects of the NASA and Boeing teams, did a nice dress rehearsal of the end-to-end recovery process from the landing to getting the crew back to Houston and even some contingencies. So feel really comfortable about return now with that happening. Once we get through all the engineering data reviews, we'll focus on return. We really like the opportunity on the 26th because it's a great opportunity into the White Sands Space Harbor, and it's before sunrise, and so the wind should be very benign and the weather should be benign. Although it is difficult to predict the weather in the desert, and with the mountain ranges and terrain effects, we'll watch that very carefully. The crew's doing well. They've been very positive about the whole thing. They love Starliner. They love being in the vehicle. They love being on ISS. I think, if you ask Butch and Suni, they might want to stay for a long period of time. I want to say how proud I am of the NASA teams. They've done a tremendous amount of work since docking. We have a little bit more work to go in front of us, but the teams are doing well. And we'll undock and land when we're ready. I'll turn it over to Dana.
All right. Thank you very much, Steve. And thank you all for your interest and for being here with us this afternoon. From an ISS standpoint, it's been a pleasure to have Butch and Suni and Starliner on board with us. Of course, we've appreciated the extra time with them and the extra helping hands that we've had. I wanted to take a minute to talk about our forward plans for spacewalks following the scrub that we had on June 13th. We are replanning that EVA for June 24th. Tracy Dyson and Mike Barrett will be our EV crew members for that EVA. The content will be the same as what we had originally planned for last week. And as a reminder, we are going out to retrieve a failed communications box that is called the S-band RF group. We're hoping to return that to the ground for repair, to return that as an eventual spare one day. We've also got some research we're going to do on that spacewalk to go swab station surfaces to look for microorganisms. We will do a second spacewalk. The content of that is a combination of the second and third that we had originally planned. We're going to go out and remove and replace a gyroscope assembly. We're going to relocate an antenna. And we've got some preparation tasks for the AMS, or the alpha magnetic spectrometer, which will have upgrades planned in the near future. That spacewalk will be on July 2nd. The crew member selections for that will be made after we complete the June 24th spacewalk. We did decide to scale back from the 3 spacewalks to 2 spacewalks, looking at our oxygen consumables on board. We actually used close to a full EVA's amount. You use a lot during the beginning portion of an EVA as you're doing the pre-breathe activities. We've got the mask crews on masks, which uses a lot of oxygen, and so we had only wanted to expend about 3 EVAs worth, so we'll do just 2 EVAs, and then we've got a resupply coming up with Cygnus on NG-21. That allows us to keep our normal kind of contingency reserve in place through the rest of the summer. As I think Dina Cantella mentioned in last week's EVA briefing, we picked these dates to work around the Starliner undock opportunity, so we don't have a conflict with our EVAs in the undock planning. The station program has supported a number of new tasks and activities with Starliner in support of the mission. We are planning to transfer some of our spacesuit water over to Starliner for use if they need it in the spacecraft's sublimator. We also used our Canada arm to do an inspection of the thrusters that Steve mentioned. We did this in front of the hot fire test, and everything looked nominal. And of course, as you heard Steve summarize, we supported the hot fire test of the Starliner on Saturday. We've also kept Butch and Suni busy while they've been on board station. They've done a number of activities in Starliner, including taking the vehicle from a quiescent powered mode to full powered mode. They've practiced what we call safe haven, which is what we would do as an initial emergency response if we had an emergency on board space station. That all worked well. They've also tested things like habitability with 4 crew inside Starliner. We had a couple station crew members join them, and they kind of went through the paces of what sleeping arrangements and air circulation and the config would be like in free flight for 4 crew. We've also taken advantage of some of their extra time and the extra helping hands. They've been helping us with a lot of research on board, and Butch has also been actively helping us with a laptop issue, so it's been nice to have an IT guru on board with the crew. We continue to be flexible on the ISS side in terms of supporting Butch, Suni, and the Starliner as long as needed. Our schedule is pretty flexible throughout the summer, as we've discussed before. We'll be ready to support Starliner's undock when Starliner and the rest of the team is ready. With that, I'll hand it over to Mark.
Thanks, Dana, and thanks for the hospitality for us to stay up on station a little bit longer. Thanks, everyone, for joining us this afternoon. I'd like to do a little bit of recap. We went into this mission with trying to satisfy 87 flight test objectives. So far, we've gotten 77 of them performed, in addition to some operational capability checkouts. And the rest that we need to go do will be performed when we do the undocking and reentry and landing. Steve said it a number of times, but feedback from the crew on the spacecraft has been very, very positive. So we really appreciate that. What I'd like to do, Steve, kind of went through a lot of the details of the tests and how the hardware's been performing. What I'd like to do is walk a little bit through the process of how we got here, why some decisions take a little longer than others, and why we adjust as we go. And we've really been taking this, step by step. When we first got into this, I talked about the phases of the mission, from launch to orbit operations to docking to undocked ISS docking, and then undocking and reentry and landing. And those are all the phases that we've been following. When we got the first phase of the mission was, our on orbit, on our way to station, we discovered that we had 2 additional leaks. So the first day of a mission management team meeting, chaired by our mission director, Leroy Kane, and the NASA Ops manager, Richard Jones, they focused on one thing. They focused on docking. And so they got the team to really lay out all the data and said, are we good or not for docking? And the answer was, we're safe to go dock. So that's what we did. And it was really well executed by the team. On day 2, after we were docked, we had the thrusters that were deselected during the docking. We re-hot fired those. And at that day 2 MMT, the focus was on, are we good for an emergency undock? The team reviewed the data, and they made the decision that, yes, we're good we have a good vehicle for safe haven and emergency undock and reentry. And so, this means we have a safe vehicle. And so then we could kind of slow down a little bit and start looking at what it was going to take for undocking and reentry. And so the mentality at this point changes a little bit. When we launch and we have a scrub, it truly is a delay. We didn't get to start the mission. But now we started the mission, we're on station, and we have the opportunity to extend a little bit, and that really is an opportunity. And I don't I think a lot of us don't look at that as a delay. We look at it as an opportunity, and in this case, a privilege to stay on station and do more work. So the team starts looking at really what we need to go do next. ISS has given us the time to stay. When we started this campaign, we said we had an 8-day mission minimum, underlying minimum. And we've always said this is a test flight and we're going to learn some things. So here we are. We've learned that our helium system is not performing as designed. Albeit manageable, it's still not working like we had designed it. So we got to go figure that out. There's some things about our flight profile and or our parameters that we've established where our thrusters aren't performing and they're being deselected at certain points in the docking phase. So we got to go figure that out. So what is it at this point we can learn based on the fact that we're on station and we're safe? Is there testing we can do? Is there more data analysis that needs to be done so we can take advantage of where we are? In addition, since we were spending more time, we canvassed the team and said, are there more flight test objectives or operational checkouts that you'd like to go do? And the team came back with a number of things, such as filming the on-orbit hatch operations, doing a second safe haven demonstration, doing some cabin temperature readings with different configurations, and then Steve mentioned earlier we did the MDR, the mission dress rehearsal for landing. Those were all things that we could go do and take advantage of the extra time, even to the point where we had initially planned to leave the landing team out at the landing site the entire mission. Well, since this is being extended a little bit, we decided to bring the landing team home, secure the equipment, bring the landing team home, and then send them back out again. That really reflects more of what a long-duration mission is going to be like. So it's a little bit more of a practice for the real long-duration missions, and we'll send the landing teams back out here 3 or 4 days prior to the actual landing date. So all that said, we did some extra testing, we did some extra operations. But the biggest thing that we can learn and benefit from is learning more about the thruster performance and the helium leak. So the team suggested that we go do that test that Steve talked about on Saturday. Good news from that, if I was to boil everything Steve said down, we do have good thruster performance now, and it's more nominal. And the leaks show that they're stable and less than previously been measured. So that's good information to have at this point. And again, that leads us to believe that we have a good safe spacecraft. So now the team has to go through all that information from the test on Saturday, from the previous flight data that we have while we dock to station, and from even previous flights. And they want to go through all that, and they want to make sure that we haven't missed anything and that we have good rationale. As Steve said, we don't get the service module back. So this is an opportunity to fully understand the system's performance, and without the pressure of schedule or time, we have the time. So the next step is to get focused on undock and return, getting all this data together, aligning on the right time to do that, let the data drive our decision making, and ask ourselves if there's anything else that we need to do before we do undock from ISS. So to get ready for that, as Steve said, we gave the team this weekend off. The undocking and landing phase of the mission is again pretty dynamic, so we want the team to be fresh, and it was a good opportunity to give the team this weekend off in order to go do that, and they came back on Monday and started to hit the ground running with reviewing all this data. The ISS community has all said that we can stay as long as we need to, and so we're not in a hurry, but we do need to get ready for a return. So with all the feedback that we've gotten from the crew, all the data that we've reviewed, we're working this week to pull all that together, get our stories all heard out by the community, and then make our decisions later in the week for the undocking. So obviously undocking and landing has a lot to do with how the weather is going to work for us and all the other variables. So I'll turn it over to Mike Lammers to talk a little bit about that.
Okay, thanks, Mark. I'm Mike Lammers, the flight director. Again, just from a vehicle point of view, as we're getting set up for docking, we have achieved all of the objectives that we wanted to do while we were docked, and you heard a little bit about those earlier. So the vehicle's in what we call quiescent mode. It's powered down. It's most of the flight computers are down, and it's just using ISS power and sitting and waiting, which was a great, actually, opportunity for my team to get ready for the longer duration missions. If you walk over to the control center right now, there's no one there. That's exactly the way we like it. We've got a monitoring system that tells us and the station team if the vehicle needs some attention, but other than that, it is just waiting for the next time it's going to be called upon. And that's really great, and it was awesome because it gives our team some time to stand down. So with that, we gave Butch and Suni to the ISS team. I know they've been doing a number of maintenance activities and payload activities over there, as well as some deserved time off. Between now and when we do more activities with Starliner, again, they're mainly doing ISS activities. We do have a few, I tag up with them occasionally. They have some onboard training that they are evaluating for future crews. That includes kind of a nifty entry trainer that they have that they can practice reentries with on the ISS side using some hand controllers that are used for robotics training. So that's kind of a neat thing, and we've been doing that. As far as looking forward to undocking, I will say that the undocking date and configuring the vehicle, it's very nimble. That's by design because we have, as we see with a lot of visiting vehicles to ISS, weather is always a factor. And also ISS, there's a lot going on, and both the ISS team and the Starliner team are great at juggling activities like the spacewalks that you heard about earlier, as well as things that we can't control like weather. So I will tell you that the next thing that we're going to do with the vehicle, no later than the 24th, which is a couple of days before undocking, we'll bring the team in. We'll power up the vehicle. It's relatively straightforward to do that. It takes about a shift. We'll go ahead and load cargo for the return in the vehicle. We'll give ISS back some emergency equipment that they stow in the vehicle just in case we'd have to leave in an emergency event. We keep that in all the vehicles attached to ISS. And then we'll be ready to do that. Again, we'll continue to look at the weather. But then at that point, no later than the 24th, the vehicle will be essentially idling, waiting for undocking day. On undocking day that morning, the crew will wake up. We'll do a final briefing with them. And then about 3 hours before undocking, they'll ingress Starliner. They'll close the hatch. We do some leak checks and make sure we're ready to go. Most of the action actually happens about an hour before undock. We'll do a final check of the weather. And then the vehicle pretty much departs in an automated fashion. There's a software will do the final configuration of the vehicle. It will bring up the undocking system. It will bring up the navigation system. It will activate the prop system. We'll go ahead and the crew has one command that they need to give, and that's to tell Starliner that it's go to undock, and it will undock at the appropriated time, which is 2:10 GMT or 9:10 Central on June 25th. After the undock, Starliner departs a lot quicker than it rendezvoused. It will back down the V-bar in front of station. 26 minutes later, it will do a burn, and it will do a we call a quarter lap. It will go up and above the space station, and at the very zenith of the station, it will do at 41 minutes after undocking. It will do what we call the departure initiation burn. That will send it out and away, and it will start phasing below space station. As that happens, the vehicle will do an automated hot fire test of the crew module propulsion system. Just a reminder, the service module that we've been talking about is used for rendezvous and undocking, but the service module is jettisoned after the deorbit burn and burns up in the Pacific, the crew module propulsion system is actually what does re-entry. So we hot fire those jets. It's a monopropellant system. It needs a bit of conditioning, and also we want to make sure that all jets in both manifolds are working for entry. So we'll go ahead and do that just after we depart from ISS. We'll phase down 3 kilometers below ISS. We'll do one last burn called the NSR about 90 minutes after undocking, and that will set us up on a co-elliptic orbit below space station as we're heading towards the point which we need to do the deorbit burn. While we're on that co-elliptic, the crew gets ready for entry. Make sure that the suits are in good configuration as well as their products, such as the procedures on the tablets. Some last configuration. We also have a couple of tests. Again, still a test flight. We still have a couple more tests that we do have planned on that co-elliptic. And then once we come up to the deorbit burn, which is 4.5 hours after undocking, we'll do the final burn of the mission. That's the deorbit burn. It's actually pretty fast. It's less than a minute. Once that occurs, the service module will be jettisoned, as I mentioned, and then the crew module will be operating on its own for entry. It takes 48 minutes from the deorbit burn until landing. Again, fully automated entry, although the crew has the capability to fly it manually if they need to. We don't anticipate that, but they're well trained and they're able to do that. And in fact, there's some there's a great deal of capability in the spacecraft to allow them to do that sort of thing manually. But we'll go ahead and do the re-entry starting at 40,000 feet. The landing sequence will initiate. There's a series of pilot, then drogue, parachutes, and finally 3 mains that will come out over the landing point at White Sands Space Harbor, which is just off the old shuttle runways. The airbags will inflate. The vehicle will touch down. The crew, the only other command that they actually need to do to land is to jettison the parachutes after they touch down. We do let some of the parts that we jettison as we're coming down fall to the ground just to make sure that the landing team is safe when they come in from their holding point, which is 4 kilometers from the touchdown point. They'll come up, approach the vehicle. You'll see first thing you'll see is a decon team arrive and just make sure that the environment around the spacecraft is safe and there's no leaks. And then they'll bring up the vehicles and open the hatch, attach cooling. It takes about an hour to do all this before you'll see the crew get out. They'll do some medical checks with the NASA flight surgeons, and then when they're ready to go, they'll be transported to the helos to be flown out to a local airfield, and then they'll be brought back to Houston. And again, really looking forward to it, and I think it's going to be a great day. Back to you.
All right. Thank you all. Thank you all for your opening remarks, the details, and the look at what's to come next. We will now move into the question and answer portion of today's telecon. So we do have quite a number of folks in the queue already. Just a reminder, if you want to ask a question, you can press *1 to raise your hand. If you hear your question asked, please press *2 to lower your hand. Additionally, because we do have a number of interested parties, please limit yourself to one question and please direct your question to a specific participant in today's telecon. So thank you all again, and with that, we will start with Gina Sunseri with ABC News.
Gave you so much confidence.
Hi, Gina. I'm sorry. I think we missed the first part of your question. Would you mind repeating?
This is for Steve Stitch. What about the RCS testing this weekend gave you so much confidence in them?
Yeah, good question. What gave us confidence is when we did the test, essentially the thruster performance looked very much like a normal good thruster. Each one of these thrusters was hot-fired at White Sands before the flight, before they got installed in the doghouses. And so when we fired the thrusters, we saw, almost full thrust on every single one. Like I talked about, 3 of them had 100% thrust. And then this way that you can see, how the thruster is performing, what I call the chamber pressure. was very much in the normal range. And so when we compared that to what we saw on docking day, each of these thrusters were performing, very much nominally. So.
Thank you. Up next is Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks so much for taking the time to answer our questions. Going back to Dana Weigel, if I may, can you just briefly describe the reason for the crew change from Matt Dominic to Mike Barrett for upcoming EVA 90? Thanks.
Sure. Let's see. During the EVA, the EVA preparations, when Matt was suited, he experienced some discomfort in the suit. We didn't want to take the time to go resolve it. We couldn't resolve it that day, and we were worried if we went out EVA, of course, if a situation gets worse and you have to terminate, we can leave the vehicle in a much worse config. So we decided to scrub the EVA. When we took a look at the fact that we were only going to do 2 EVAs going forward, and we had already planned for Mike to go out, so we had a suit ready for him instead of taking the extra time with all the other activities going on board around Starliner, we decided it just made sense to go ahead and use Tracy and Mike, who were going to do EVAs anyway in this series.
All right, thank you. Up next is Eric Berger with Ars Technica.
Hi, thanks very much for doing this. I guess this is for Steve Stitch. Just curious about the timing of Starliner 1. Would love some thoughts on how long the post-flight analysis and resolution of the RCS and helium issues are going to take, and then the certification process. Right now, I guess theoretically that mission could fly early in 2025, but at this point, is it more likely to move to the second half of 2025, given that the work you've got to do to resolve these issues? Thank you very much.
Yeah, thanks for the question, Eric. Yeah, we really haven't looked that much at Starliner 1. I would say the whole team has been focused on understanding what's happening with this vehicle for the crewed flight test and our plan for return. So we haven't looked ahead too much to Starliner 1. As Mark said, we know we've got to go, address the helium leaks. We're not going to go fly another mission like this with the helium leaks. We've got to go understand what the rendezvous profile is doing that's causing the thrusters to have low thrust and then be deselected by the flight control team. So we've got some of that work to do, after this flight. We haven't really had a chance because we want the teams really focused on this flight, so we haven't had a chance to lay out those details yet. But we'll do so at the right time, later this summer, lay out all the work in front of us after this vehicle comes back with the crew, and then figure out what the path forward is.
Thank you. Up next, we have Elisha Sowers with Mashable.
Hi, thanks for taking my question. This is Elisha Sowers. So after Starliner docked, it seems like it took a considerable amount of time for the crew to actually open the hatch and then enter the station. You could see the astronauts waiting for Butch and Suni to enter were looking like a little puzzled and restless, and frankly, so were the commentators on the broadcast. Could you shed some light on what was going on and what caused that delay, and were there difficulties actually opening the hatch? Thanks.
Yeah, this is Mike Lammers. There were no difficulties in opening the hatch. I am familiar with what you're talking about. We were just it seemed like we were waiting a while there. I will tell you that the hatch, after the crew docks, of course, we do a number of leak checks with the vehicle, and then when they take the hatch out, the hatch is actually completely free floating, and it's a hatch. You want to be very careful with it. So there's a cover. There's an inspection that the crew does. There's a cover that they put on, and then they put it off to the side in an area where it won't be bumped or jostled, right? Because we need to have a good sealing surface with that hatch when we put it back. So there was nothing wrong. There was nothing unusual. I've done in some of my other jobs. I've done dockings with other vehicles, and the crew is the ISS crew is pretty excited, and they're there and they're setting up. And perhaps they were a little early there. We made it so that they had the availability to be there early as far as the timeline. So that's kind of the answer. It wasn't nothing wrong. It was just sort of the outcome of doing this for the first time.
And it was great to see them float through the hatch. Up next, we have Jonathan Siri with Fox News.
Thanks so much for doing this. This question is for Mike. What time on the 26th is Starliner expected to land? Is this something you can predict to the exact minute, the exact second, or is there a range? And similarly, for the landing location, how wide is the potential area where it will land? Thank you.
Yeah, so the landing time, as Steve mentioned, is 2:51 Mountain Time, and that won't vary by more than a minute as we approach it. It's all defined by the ISS orbit, and that doesn't change a whole lot as it goes week to week as we monitor it. So whenever you hear Steve give a number in his conferences, it's going to be pretty close. As far as where it lands at White Sands, it targets what we call the 4-kilometer radius circle, and that's where you want to land. Now, it actually does a guided entry to the center of it. It usually hits well within that 4-kilometer circle. In fact, we actually look at the wind's upper level, and we bias the landing point a little bit, and we try to hit the middle and hit the bullseye, and there's a little bit of informal scoring with the folks doing that on how close you get. So, but it should be within a few hundred, certainly 4 kilometers. If it was within half a kilometer, I would not be surprised. Also, I just wanted to point out we do have a landing opportunity. It repeats every 4 days. Again, we're trying to be flexible because we do contend with the weather. So you can expect where we are in the ISS orbit right now that we'll have an opportunity every 4 days. So we have the one to White Sands on the 26th, and then we'll have a follow-up on the 30th, and so on.
All right, thank you. Up next is Jeff Faust with Space News.
Hi, question for probably Steve. Does the fact that the helium leak levels dropped when you were doing the testing over the weekend provide any guidance on what might be causing the leaks? Does it narrow down any potential root causes in any way? Thanks.
Yeah, thanks. Great question. I think that's what we are in the middle of trying to work out with our engineering teams as we look at the particular systems. What it kind of tells us is there's got to be some kind of effect either from the thermal as the thrusters fire. Obviously, as it creates thrust, it creates some heat that soaks back into the system, and then also there are some sliding surfaces. When each thruster fires, the helium is used it comes into the thruster and then it pushes a couple of valves open so that the propellant, the monomethylhydrazine, and then the nitrogen tetroxide can come into the thruster. And so it might mean that those seals wear a little bit and then have some heat effects. It does give us some confidence as we move forward, as we look at this quiescent phase where the leak rates have gone down, that, when we compare what we are going to do on the on-dock period with the rendezvous day in particular, the demand on the thrusters is much, much less. The last really big dynamic activity is the deorbit burn, as Mike talked about. It's a short burn, less than a minute, and so that's giving us some confidence relative to managing the system. But we're really trying to look at the data and understand why did the leak rates change on the docking day? They went up a little bit from what we had. Also, interestingly, in the crew sleep period between the first day of the mission and the docking day, the leak rates didn't change at all in that quiescent period. So we're looking at all that data and trying to figure out if it points to a certain kind of seal or not. So.
All right, up next we have Elizabeth Howell with Space.com.
Hi, everybody. Thanks for taking the time. This may be for Dana. Can you clarify if the spacewalk, the June 24th one, is delayed for any reason, if that would in turn affect the timing of Starliner's departure? Thank you.
Great question. No, we'll prioritize Starliner's departure. So if for whatever reason we ran into some other issue with the EVA, we'll push it past the planned undock. So we'll make sure that we work around the Starliner schedule.
Thanks, Dana. And next up, we have Jim Siegel with Florida Media Now.
Hi, everybody. Thank you for taking my question. I have a follow-up about those helium valves. I'm curious about whether all of those valves came from the same supplier. And what supplier was that? And did all these valves come from the same lot as well? That kind of question I have.
Yeah, Mark, you want to take that one?
Yeah, these are helium. This is actually not a valve. This is a flange between the thruster and the manifold itself, where there's seals where the helium port is, and we believe that the culprit is in this seal area. So it's really not a valve. So I want to clarify that right off. And we are working with our supplier of this propulsion system. They've been helping us understand this and help us work through the fault tree to understand, what the potential causes are and how we can remedy this in the future.
Did they all come from the same supplier?
This flange area and these seals, yes, do come from the same supplier and sub-supplier.
Okay, thank you.
Up next, we have Joy Roulette with Reuters.
Hey, thanks. Question for Steve or Mark. What is the minimum number of thrusters or the slimmest configuration in the propulsion system required to proceed with deorbiting? Thanks.
I think that's a great question, and it's really difficult to answer because each phase of the flight requires certain thrusters, and so we have a flight rule that governs that. For example, during rendezvous, that's probably our highest demand for the redundancy as we approach the ISS. For certainly backing away from station and the undock, it's quite a number of less thrusters required for that. Then for the deorbit burn, it's a number of thrusters required. The OMAX, as we've talked about before, right? One in each doghouse fire to do the excellent burn itself, but then the RCS thrusters provide attitude control. And then after that, there's a number of thrusters that are required to separate the crew module and the service module. And then once the service module separates, it actually spins up and does a disposal burn. And none of the aft thrusters, as a matter of fact, are involved in that process of spinning the service module up and then either separating away from the crew module, spinning it up to a certain RPM, and then doing the disposal burn. So it's hard to give you like a certain number of thrusters because each are required for different events. And so that's one of the things we're looking at very carefully is like what are the demand on the aft thrusters for the remaining part of the flight relative to the separation burns and then the deorbit burn in particular.
Is it not decided yet, or do you guys know and it's just you don't know off the top of your head right now?
I do know for each phase how many thrusters are required. I don't have it with me off the top of my head of each phase what we require. So
is that?
Sorry, I think we lost you. Next up, we have Lauren Grush with Bloomberg.
Hi, thanks for taking my question. It's for Steve or Mark. So regarding the helium leaks, is it correct to say you think this is a shared issue causing all the ones you've seen so far? I think before you had said the helium leaks were separate from the thruster issues, but now you think there is a connection. And do we know why they started to appear during flight and not during the ground testing to better understand the first leak that you found ahead of the flight?
I think we've spent some time looking at the two issues to see if they're combined. And when I went and looked at the particular doghouses that we are seeing the leaks in and compared them to where we are seeing the thrusters fail off, they are quite different. Now, the one common thing might be the thruster firings themselves. So, each thruster gets a number of firings in flight. And so what we were seeing is pre-flight on the helium system, we had the one leak, the P2D2 flange leak. Mark's team did an awesome job taking that doghouse cover off and doing a check to look for the helium leakage from various points, and they found only this one area, what we call this P2D2 flange, that leaked. I think the complexity on orbit now is not only do you have the flanges, but there are also some other areas as you actuate each thruster with helium that have some sliding seals that could leak a little bit. And so it appears from the data at least that dynamic operations on flight day one, where we fired the OMAX twice for the insertion maneuver and a phasing maneuver, and then also the crew did some attitude maneuvers, part of the operational checkouts that we did, that seemed to create some leaks, and then also after docking, we had two smaller leaks. So they seem to be related a little bit to the rendezvous or thruster firings, and that's why we couldn't see them on the ground. On the ground, all we have is a static system, so we can cycle valves and repressurize the flanges, but that's why we didn't see them on the ground, and we saw them on orbit.
I think I'd add to that, Steve. It's the question, and that's the question that our engineers are asking of themselves, and that's what has gone into the thought process of what other testing do we want to go do while we have the opportunity. That's what drove Saturday's test, and they're just going through the data now so that they can compare all those parameters and determine, is there anything else we want to go do, or is there enough there for us to make this determination? And again, the determination is so we can fix this in the future.
Thank you both. Up next, we have Bill Harwood with CBS News.
Thank you very much. This is, hang on a second. Take it off speakerphone. This is for Steve. We spent nearly an hour here reviewing problems you guys have had to deal with and all the ongoing work to reduce, the uncertainty in the analysis. What is your overall confidence level in the vehicle at this point? Should we have any realistic concern about these problems in terms of a safe reentry and landing? Thanks.
Yeah, I think as Mark said, we already have cleared the vehicle for any kind of contingency or an emergency. We would be very confident in putting Butch and Suni in this vehicle and returning them if we need to. I think we will work through each of these issues, and we will get to a point where we can bring Butch and Suni back in Starliner. I think we just want a little bit more time to understand what's happened with the data that we have and work through that. Certainly Saturday was a big day of understanding the helium leaks have gone down and also understanding that the thrusters have recovered and that we can count on those thrusters for the remainder of the flight. I think now we're doing the normal business that we typically do of what are the contingencies that could happen between the undock time frame and when we get to the return. How will we manage each of those contingencies should something happen? And then look at the flight rules that we have in place, the procedures we have in place. Are we ready to execute those? And then the same thing with the thrusters, right? If we should lose one of those thrusters, is it acceptable? We don't think we will lose them now based on the confidence we got out of Saturday, but we're kind of going through all that as we get ready to return Butch and Suni on Starliner.
Next question is from Marina Koren with The Atlantic.
Hi, a question for Steve. Before the launch attempt in May, Boeing said that it was working at peak performance, and before the launch in June, they said all is well. We all obviously understand that this is a test mission and that issues will come up and get resolved. But are you characterizing this as peak performance, and has this been frustrating for NASA? Thanks.
Yeah, I would say, I expected with a test flight that we would learn. I think Mark talked about that prior to the flight, that we would learn something on the flight. I think we've learned on OFT, the uncrewed orbit flight test. We've learned on this flight. We're taking our steps methodically through learning about the vehicle. I think one of the things about the service module, it is a very complicated module. It has lots of thrusters, and I think, their interaction perhaps on the day that you fire the OMAC engines with the RCS system in terms of heat from that system going back into those dog houses and affecting other thrusters. I think that's what we're understanding now during the flight. And so perhaps we could have done different testing on the ground to characterize some of that ahead of time. We did a series of tests called the service module hot fire testing at the White Sands test facility as well. And now we're kind of working through learning about this vehicle, and we're learning about it in a different way. I stepped back and look at Dragon and SpaceX, and they were able to learn a lot about flying in space with their cargo program ahead of Demo 2. They had many cargo flights they flew to learn and develop their system, and here we are now on our third flight still learning. I'm an engineer. I like to learn, and I think our team likes to learn, and I would not characterize it as frustration. I would characterize it as learning.
Thanks, Steve. Next up, we have Chris Davenport with the Washington Post.
Hey, I think this is for Steve Stitch. When you're talking about taking some extra time, to now come home on the 26th to review the data on the thrusters, is this related at all to safety concerns, or is this purely to gather more data and information about the vehicle, given the fact that you're going to lose the service module? I know you said it's clear to come home in an emergency situation, but if it wasn't for this data gathering time, would you feel comfortable having them come home in a sort of non-emergency situation now as well? Thanks.
I think one of the key points really was Saturday hot firing the thrusters. We really wanted to understand those thrusters and the performance of the system by hot firing those thrusters and seeing if they came back. We had, many of us, including myself, had a theory that they were going to return just like on OFT2, and when we hot fired them, we saw the thrust come back. So I think we're taking our extra time, given that this is a crewed vehicle, and we want to make sure that we haven't left any stone unturned. We also want to look at the systems and potential interaction between the systems and make sure we haven't missed something before we return. And we're getting a lot of great data while we're at the space station for not only this flight but for the next flight. And we're also learning in the process of how to fly the increment flight. If you remember Demo 2, we flew that flight for about 2 months with Bob and Doug. And so I like the fact that the vehicle's staying a little longer. I like the fact that we're watching how the vehicle performs thermally, how the space station charges the batteries. We're getting to see those kind of cycles, which we absolutely need for the increment missions, Starliner 1 and subsequent missions. And we would not be able to get that data on the ground. We would not be able to get this interaction with the space station on the ground. And so I think there's a silver lining in staying a little extra time, and we can learn more about the increment flights and be prepared for Starliner 1 at the right time.
Thank you. Next up, we have Kristen Fisher with CNN.
Thank you. And just to follow up on that last question, Steve, just want to be really clear here. You said that, Starliner was cleared to come home in an emergency, but would it be cleared now to come home with a crew? Like, is this a situation that's actively being discussed, whether or not Starliner is comfortable, whether or not Starliner is safe right now to bring a crew home?
Yeah, obviously we wouldn't say Starliner is safe to bring a crew home in an emergency if we didn't feel confident in the vehicle's capability. We're taking a little bit of extra time to work through what we've seen and make sure we have all the plans in place to bring the crew home in a nominal situation for the end of mission. So we're just taking a little more extra time to review all the data and also learn as much as we can while we have this service module in orbit.
So is there any chance that these leaks and thruster issues could lead to a situation where Starliner can't bring Butch and Suni home?
So far, we don't see any scenario where Starliner is not going to be able to bring Butch and Suni home. We really want to work through the remainder of the data. When we talk about looking at the thruster pulses for the entire flight, for example, some of these thrusters have fired 1,000 times. And so we want to go back and compare the data all the way across the flight for all the different regimes where we're going to do some similar maneuvers. And so that's just taking some time to pull all that data and make sure we understand the thruster performance. So we're taking it one step at a time, looking through all the data. And when we close these things out, we'll be ready to return Butch and Suni on Starliner.
Next question is from Irene Klotz with Aviation Week.
Good afternoon. For Mark, just for clarification, does preliminary analysis show that the RCS flange seal that caused the leak pre-launch is different than the 4 leaks that have surfaced since flight and docking?
I think what we've, the engineering teams are concluding is that the 3 are of the same magnitude leak. They're likely similar. The other 2 are much, much smaller and may be from a different source, but there's no way we're going to be able to prove that. They're much more similar to what we had experienced on OFT2, and we did attribute to a valve leakage itself. So I think we're going to have to work through that and determine, what exactly we're going to do with that seal interface, and then assume that it could be in a different area and address that one as well.
Thanks. And does NASA plan to have another briefing ahead of undocking?
I think we'll look at that and determine whether if there's new information, obviously we will. If there's something that has changed since we talked here, we'll have another briefing. But, if we resolve and clear these last two items through our normal process through the Starliner mission management team, and the weather looks good and we don't have any other significant items to talk about, we may not have another briefing.
And we've also been sharing updates at blogs.nasa.gov/commercial-crew, so you can always check there for information as well. Next up, we have Micah Maidenberg with the Wall Street Journal.
Thanks, Leah. Hey, Steve, just to go back to the discussion a moment ago, right now, is Starliner out of bounds for reentry criteria, given the issues under review? And then you talked about how you don't see a scenario where Starliner wouldn't be able to bring back Butch and Suni, but could you explain a little bit about, what would trigger a possible switch where, the team would start looking at alternatives instead of, pushing to resolve the issues at hand with Starliner? Thanks.
Yeah, if I look at the flight rules and the capability of this vehicle relative to deorbit, undock, deorbit, and entry, we have one thruster down relative to our flight rules. That's the thruster that I talked about, that when we hot-fired it on the day of docking, it showed a very strange signature. The first time it only showed 11% thrust, and the second time basically no thrust. And so that one looked really funny. And so we decided, hey, out of the abundance of precaution, we're not going to use that thruster. So we have one thruster down. And then in terms of the helium system, we need about 7 hours of helium. That's at the current leak rates. Actually, the leak rates at docking, not the leak rate we saw 9 days after undocking or docking. The one we saw Saturday, we have even more margin. Instead of having a total capability of 70 hours, we have more than that. So, and we can still manage those manifolds. So right now, the vehicle is capable of undocking. It's capable of with the helium usage coming home, and we could even wave off, and we would still basically have double the amount of helium that we need for the flight. So that's with no management. That's without Mike or his team closing any of the manifolds. And so the vehicle is capable of coming home. That's why we've said it's acceptable for any contingencies today. It would be much preferable to have Butch and Suni use that vehicle. We just really want to go through our process and close out these last two items through the Starliner mission management team before we give the go-ahead to proceed to the nominal undock and entry.
Thank you. And next up, we have Kenneth Chang from the New York Times.
Hi, thank you. This is for Mark or Steve. There's only one launch landing opportunity once every 4 days. Is that are there tighter constraints on landing opportunities because Starliner lands on land? Thank you.
Yeah, the way. Oh, go ahead, Mark.
Well, I was going to say that's a good question for Mike.
Yeah, it's interesting because the landing sites are fixed and they're all in the Southwest United States, and so essentially you're depending on space station to fly over them. You have a little bit of what we call cross-range capability where you can steer left or right. But it's a capsule, so capsules are a little bit different than the space shuttle where you can only steer left or right by about 50 kilometers. So that is the pattern that gets set up is really driven by when the space station overflies, and then that's driven by what its altitude is. So right now you're in this every 4-day pattern, and again, we like to have a primary, and then we always have, we didn't talk too much about this, but whenever we undock, we don't have just where we're going to land 6 hours later. We also have to have a backup behind us just out of precaution if we're not able to do the deorbit burn. We always have a backup either 24 or 31 hours later that has a good weather forecast that we're available to land at, and that's why you get a 4-day pattern right now.
Thanks, Mike. Next question is from Tim Fernholtz with Payload Space.
Hello, thank you for taking the question. One for Steve or Mark, just to clarify on the helium leaks. We're now saying that there are sort of 2 categories, 3 that are larger, 2 that are smaller, with probably different sources based on the preliminary analysis. Was the leak discovered on the pad, the first leak, part of the 3 large magnitude leaks? And are those the ones that you think are related to the firing of the thrusters, or are those the 2 smaller leaks? And then a question for Dana on the spacesuit discomfort issue. Am I right in understanding that the solution to that is just switching to a different astronaut? Are there any reviews or investigations of the suit itself that NASA has to do to ensure that this doesn't happen again? Thank you.
I think start with the first question. First of all, I wouldn't characterize them as large leaks. They're larger leaks than the other 2. Both of these, all these 5 leaks are what we called in the manageable state. Remember, prior to launch, we looked at the leak that we had, and we said we could tolerate 5 of those and still be within a manageable range of flying the vehicle. And so we didn't expect to get more, but we had planned for more. So I think it's safe to say that those 3 are probably similar in nature, and the other 2 that are smaller, we're just not going to know. They can be similar in nature, they may not. We'll conduct a fault tree, and we'll go through all the probable causes, and even though we might have a most probable cause and we'll address that, we'll also have some other probable causes that we'll also address in order to eliminate this once and for all.
Let's see, to answer your question about the suit, before we send the crew out to do a spacewalk, we typically do a pressurized fit check with the suit, and we try to work through any discomfort issues. Sometimes we're successful, sometimes we think we resolve it, and we didn't get it all the way. So what we would do if we needed to go look further into this, we'd probably go set up some additional suit time, meaning suit fit check time. So not an investigation, but just a process that we go through anytime someone has discomfort in the suit.
Next question is from Anthony Ione with Spectrum News.
Hello, everyone. Thank you so much for taking our questions today. My question is for either Steve or Mark. These issues that popped up, the helium leaks and thresher issues, it seems as if they would have been discovered if this was an uncrewed mission. Going forward, would NASA and Boeing consider one more uncrewed Starliner mission to make sure all these issues have been resolved before launching the crewed Starliner 1 mission next year?
Yeah, Mark and I haven't talked about the next steps, right? I think on the ground, on the helium leaks, we've got to go look at all the different, we know the potential sources, we know where the seals are and the various valves and the flanges that are in the system. There's a number of welds in the helium system. Think of it as a pipe, right, that basically goes to each of the thrusters. Very unlikely that the welds are a factor at all. It's likely places where there's dynamic activity. I think we can on the ground, and it may take some time to go figure out where all those sources are and how much leakage could happen in each of those. Multiple thruster firings. Is there some limit to the number of thruster firings we need on each of those seals? So it's kind of an integrated problem. I think we can do all that work on the ground without requiring an uncrewed flight test. But I'll turn it over to Mark and see what he has to say.
I agree with Steve. I think, I characterize these problems as learning and additional fine-tuning that we need to do to the vehicle in order to get to a certification for our vehicle. I don't see these as safety of flight types of issues that we would have to go fly an uncrewed vehicle to further demonstrate the system. We're still learning, and again, I'll put this in the fine-tuning category.
Next question is from Ryan Caton with NASA Spaceflight.
Hey, thanks for taking my question. I'm not sure if this is best suited to Mark or Steve. If similar leak or thruster issues are encountered during Starliner 1, the first operational mission, will these problems for future missions just become an item which you'll have to deal with every single mission, kind of like a quirk of the spacecraft when you're operating it? Thank you.
Yeah, I think our goal, Mark and mine's goal, is to get the quirks, as you call them, out of the system before we get to the phase where we will be, using this vehicle to rotate up 4 crew members and then bring them back at the end of 6 months. So I think we got to go just work through what we're going to go do for Starliner 1 after the crewed flight test and try to understand what those changes are. Certainly, one of the things that there's been discussion of already is should we change the aggressiveness of the rendezvous profile on the thruster? In other words, is there a way maybe to not quite fire the thrusters quite so much? And you can do all that work if we go change the way that the vehicle flies and the number of thruster firing. Since we have such great data now on 2 dockings, we can do all that via analysis on the ground and compare it to the flight data of how the firings of the thrusters affect the thrusters themselves in terms of the thermal piece. So I think we can do a lot of that work on the ground, and we can maybe eliminate this for Starliner 1.
I would add, Steve, that we fully intend to eliminate these, call them nuisances for the flight. The good thing about the situation that we have is that, we can stay up on IS a little bit longer, like we talked earlier, and get as much data as we possibly can so that we can fully understand this or understand it to the best of our ability so we can eliminate it. And our intent is to fully eliminate these issues.
Thank you both. Next question is from Manuel Mazante with Exploration Especial.
Thank you very much. A question for Dana. Dana, you mentioned that several tests were done on Starliner. One of them was the habitability test with 4 astronauts inside, even sleeping there. I wonder if you have any initial feedback from them and if there's any potential modification that needs to be done before Starliner 1. Thank you.
Yeah, good question. No modifications at all. They were really more looking at orientation. When you're in free flight and you're floating, how you place crew members for sleep and how you kind of manage daily activities in the cabin is a little bit different than what you're able to practice on the ground. So what they were really looking at is just different configurations for how they would do things for future missions when they do have 4 crew on board. So everything went well, no modifications. As folks have stated before, we're continuing to learn and just take every opportunity we can to check out everything we can on the spacecraft to be ready for our eventual longer duration missions.
Our next question is from David Curley with Full Throttle.
Thanks very much. Steve Stitch, can you explain, I understand the thruster testing and everything else, why the safe haven test again? And do you think any of these issues push certification down the road? And Dana, can you give us any sense what Matt's discomfort was?
Yeah, I'll start. In terms of certification, we've got to go look at what all this means to that once we come back. I mean, it's possible that there's a change in some of the dates that Mark and I are talking about for certification, but we just haven't really had a time to lay all that out, right? We're in the middle of the flight. And what was the first question again? I'm sorry.
Safe haven.
Safe haven. Thank you, Mike. Safe haven is a requirement that we placed on these vehicles. So what it basically means is that the spacecraft is a safe place to go. So, for example, if there was something that was occurring on the space station where the crew needed, if there was a potential alarm that said there was a potential ammonia leak on station, the station has ammonia loops on the outside. Those then transfer heat over to a water loop, and then the water loop provides cooling to all the avionics and components throughout the space station. There's some scenarios where you can have ammonia, which is a very hazardous chemical, may potentially leak into the ISS atmosphere. And so one of the contingencies we practice is have the crew get in Starliner and close the hatch, and then they're safe until we understand the situation on station. There's several of those other scenarios. We've also, at various times, put the crew in these vehicles for MMOD as well. So if there is something that's coming close to the station that we couldn't maneuver for some reason, we have the crew get in the Starliner spacecraft. So the idea is you get in the spacecraft, you close the hatch, and the vehicle is able to sustain the crew for a period of a day with food, water, power, and all those sorts of things until the space station program and the community can resolve whatever issues on the space station. So that's the whole concept of what we call safe haven. I would think of it as like, on the ground, you have many places have a storm cellar or a room, a safe room to go to during some event, like a tornado or something that's going to come by. You go in a safe place, you stay there for a period of time, and then when the tornado clears, you get out of that room. And that would be my analogy for what a safe haven is.
My question was, why the repeat?
Oh, why the repeat? We had a little bit of a glitch with one of the Starliner systems we wanted to understand, and then we went back in and repeated that. I'm sorry, I didn't understand the question.
Can you tell us which system?
Pardon?
Can you tell us which system was problematic?
We'll let Mike talk about that.
Yeah, it's Mike. That procedure just involves powering up. The crew goes in and powers up the electrical system. They bring up the batteries and the buses. And there was a really the first time we did it, there was a little bit of a minor finding when they connected the batteries to the electrical bus, and we just want to go back and repeat it. I would call it kind of minor and procedural, and exactly the reason why we want to do this with the vehicle and the space station, because it's really the only place to try it. So we resolved all that, and the procedures as they exist today are good.
Of course, that's the first time we've actually put Starliner in this safe haven mode. So to have an unexpected glitch in that process is not a surprise.
All right, thank you. Next question is from Holly Chick.
Hi, I have a question for Steve about private-public partnerships. Taking Starliner as an example, how do you see the division of responsibilities between NASA and commercial providers evolving in the coming years? It would also be great if you could shed light on any potential commercial space station plans in the future. Thank you.
Yeah, we've been embarking Commercial Crew to have this public-private partnership for a number of years now, and I think it's worked very well, demonstrated by the fact that we now have, 2 vehicles flying back and forth to the International Space Station with crew. The responsibility piece is we've, over time, continued to transition a little bit more over to each of the contractors. I would say what we are doing is leveraging the strength of the companies that we have in place, and what NASA can assist with varies depending on each company, and I think we have a good teaming approach between both of our providers and how we divide up responsibilities and divide up getting ready for the missions. Obviously, for every single mission, NASA is responsible for the certification. So if there's any changes to the vehicle, we have to look at and understand those and approve those. If there's any in-flight anomalies from the previous flight, we have to go approve those with our team. If there's any new analysis required, sometimes we will do an independent analysis of those. That's the beauty of what NASA can do, and I'll see if Dana has anything to add.
Yeah, I'll just add that the balance between NASA and a provider is different depending upon what we're doing. So obviously criticality is very high when we're looking at our crewed missions, and so we've got much heavier involvement on the NASA side. We also have similar arrangements and agreements for cargo missions in terms of a contractual setup, but the agency's oversight and the requirements that we levy and what we require for integrated certification is very different for something like cargo, which carries a slightly lower level of risk. In terms of where the agency is headed in the future for future space stations, I think some of the agreements will look similar, but again, the balance between NASA and the providers will be determined based on the risk and the scope of the specific work.
Thank you both. Our last question today is from Joey Roulette with Reuters, since you got cut off previously. Sorry about that, Joey.
Yeah, no worries. I was going to ask Steve if NASA would be able to make those numbers available as far as how many thrusters or what kind of configuration is required for each phase of Starliner's return. So I guess I'm asking, will NASA make that available? And then also I just wanted to get more clarity on the oxidizer valve issue and the potential resolution for that, what you guys have done so far. Thank you.
I think we can provide some summary of what capability is required for each phase. We'll work with the Boeing team and figure out how to describe what we need for each phase in terms of undocking, separation, the deorbit burn, and then the service module, separation from the crew module, and then the disposal sequence. Yeah, the aux valve, that was just a separate valve that was just slow to seat. And essentially, we can see that we have instrumentation that tells us that it moved and closed, but then remember the pressure is about 700 pounds per square inch, so it's pretty high pressure. So if it doesn't seat all the way, it can move just even drops or a small amount of propellant between that. So when we saw that happen, every single system on Starliner has a redundant component. In this case, we used the backup valve to cycle it closed. So we've cycled that valve a few times. The backup valve's working fine. So we'll use what we call the B valve to isolate that manifold as necessary. And that's been closed for the rest of the flight. So.
All right, thank you all for participating, all of our speakers, and to all of you who are dialed in today. We really appreciate all of your questions and your interest in NASA's Boeing Crew Flight Test. For the latest updates, you can always visit us at blogs.nasa.gov/commercial crew, and we will share departure information as that becomes available. Thank you all again. Go NASA, go Boeing, and go Crew Flight Test.